Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So today we are back with another session, and in this session we are going to deal with NEET 2017 physics questions, and we have 45 questions here. So let's start the session. The first question is related to simple harmonic motion, and the question is a spring of force constant K is cut into lengths of ratio 1:2:3. They are connected in series and the new force constant is K dash. Then they are connected in parallel and the force constant becomes K double dash. Then the ratio of K dash and K double dash is. Okay. So we have to first find the K dash and then K double dash, and then we have to find the ratio of these two, right? So let's see. We have a spring. Suppose this is your spring. Now it is cut into three pieces in the ratio 1:2:3, right? So this is L1, this is L2, this is L3. Okay. These are the lengths of individual pieces. These are in the ratio 1:2:3, right? And suppose the spring constants are K1, K2 and K3 for these three pieces. So we know that the product of spring constant and length remains constant. That means the spring constant is inversely proportional to the length. Now we don't know what is the ratio of spring constant, but we know what is the ratio of length. So we can find the ratio of spring constants as well, right? K1 is to K2 is to K3 will be equal to 1 by L1 is to 1 by L2 is to 1 by L3 because it is inversely proportional, right? So we can write 1 upon 1, and 1 by L2 will be 1 by 2 and 1 by L3 will be 1 by 3, right? Now if we solve this, we can just simplify it by taking LCM. So let's do it here. 1 by 1 is 2, 1 by 2 is 2, 1 by 3. Now LCM of 1, 2 and 3 will be 6. So 1 into 6 is 6, so it will be 6 here. 2 into 3 is 6, so it will be 3 here. And 3 into 2 is 6, so it will be 2 here. So if we can just ignore the denominator and write 6 is to 3 is to 2. So this will be the ratio of spring constants of these three pieces, right? So we have just simplified it. Now we can find the spring constant in series combination. So in series combination, that is K dash will be same as that of the original spring, right? Same as that of original. Because in case of series combination, what do? We'll just add these three pieces. So it will become same as the original one. So the spring constant will also remain same. Okay. So K dash will be equal to K only. Now in case of parallel combination, that means we have to find the K double dash, right? So it will be the sum of spring constants of the individual pieces, that is K1 plus K2 plus K3. So that is equal to 6K plus 3K plus 2K, right? Because the ratio is 6 is to 3 is to 2. So it will be equal to 11K. So K dash is equal to K and K double dash is equal to 11K. So can we find the ratio? K dash by K double dash will be equal to K upon 11K. So K is cancelled. 1 by 11 is left. That means this ratio is equal to 1 is to 11. Okay. Therefore, option B will be the correct answer. Question number 2 is from the chapter Ray Optics and Optical Instruments, and the question is the ratio of resolving powers of an optical microscope for two wavelengths lambda 1 equals to 4000 angstrom and lambda 2 equals to 6000 angstrom is. Okay, so there is a simple concept here. The resolving powers of an optical microscope is inversely proportional to the wavelength. Okay, so the resolving power is inversely proportional to the wavelength. That means since we have to find the ratio of resolving powers, so resolving power 1 upon resolving power 2 will be equal to lambda 2 upon lambda 1, right? Because these are inversely proportional. So lambda 2 is given as 6000 angstrom, and lambda 1 is given as 4000 angstrom. So zeros are cancelled. It will be equal to 6 upon 4. So we can simplify it. 2 into 3 is 6. 2 into 2 is 4. So the ratio will be 3 is to 2. Right? Therefore option B will be the correct answer. Now question number 3 is from the chapter Wave Optics, and the question is the two nearest harmonics of a tube closed at one end and open at the other end are 220 Hz and 260 Hz. What is the fundamental frequency of the system? Okay, so we know that for the tube that is closed at one end and open at the other end, the value of length in case of nth harmonic is given by the formula 2n minus 1 into lambda upon 4. Okay, so lambda is the wavelength, but wavelengths are not mentioned in this question, rather frequencies are mentioned, right? So we can write it in terms of frequency because lambda is equal to velocity upon frequency, so it can be written as 2n minus 1 into velocity upon 4f, right? F is the frequency. So what will be the value of frequency? It will be equal to 2n minus 1 velocity upon 4L. Okay, so L has come towards the right hand side as denominator, right? Now we know that for this type of closed pipe, the fundamental frequency is equal to velocity by 4L. Okay, that means this velocity by 4L is nothing but the fundamental frequency. So we can write f dash in place of fundamental frequency. Okay, so it will be equal to 2n minus 1 into f dash, and the value of this frequency is given as 220 hertz. Okay, so 220 hertz is equal to 2n minus 1 into fundamental frequency. So let's say this is equation number 1. Now for the next nearest harmonic, the value of length will be equal to 2n plus 1 minus 1 into lambda by 4. Okay, that means the same formula is applied here, just in place of n we have written n plus 1. Okay, so again we can write it in terms of frequency, so it will be, on solving this we'll get 2n plus 1. Okay, and lambda by 4 will be equal to velocity upon 4f. So again we'll write frequency equals to 2n plus 1 velocity upon 4L, right? And the value of this frequency is given as 260 Hertz. 260 Hertz equals to 2n plus 1, and V by 4L can be written as fundamental frequency, that is F dash. Okay, so this will be equation number 2. Now we can solve equation 1 and 2 to find the value of fundamental frequency, right? So on subtracting equation 1 from equation 2, so equation 2 minus equation 1 will get 260 minus 220 will be equal to 2n plus 1 f dash minus 2n minus 1 f dash. Okay, so let's solve it further. We'll take f dash common. Here we get 2n plus 1 minus 2n plus 1 again, right? On opening the bracket it will be plus 1, and this side 260 minus 220 it will be 40 hertz. So 40 equals to fundamental frequency into 2n will be cancelled, 2n minus 2n 0, 1 plus 1 will be equal to 2. Okay, so 2f dash is equal to 40. So what will be the value of f dash? F dash will be equal to 40 divided by 2, that is 20 hertz. Okay, so the fundamental frequency is equal to 20 hertz. That means which option will be the correct one? Option number A will be the correct answer. Question number 4 is from the chapter Work, Energy and Power, and the question is, consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second. Take G constant with a value 10 meter per second square. The work done by the gravitational force and the resistive force of air is. Okay, so we have to find the work done in two cases. First by the gravitational force and second by the resistive force, right? And what is given in this question? Mass of water is given. So mass is 1 gram, that is equal to 10 to the power minus 3 kg. Okay, so we'll use this data. And then height is given. Height is equal to 1 kilometer. So we can write it as 10 to the power 3 meter, right? and then speed is given as 50 meter per second. G, that is acceleration due to gravity, is constant, and that is 10 meter per second square. Now let's see the first one, that is work done by the gravity. Work done by the gravity, that is Wg, is equal to mgh. Okay, the simplest formula. M is mass, and that is equal to 10 to the power minus 3 kg. G is acceleration due to gravity, that is equal to 10 meter per second square. Height is 10 to the power 3 meter, right? 10 to the power 3, and the unit of work will be joule. So on solving this, we'll get 10 joule. So this is the amount of work done by the gravity. That means option C should be the correct answer, because it is the only option where work done due to gravity is mentioned as 10 joule. But still we'll find the work done by the resistive force of air as well. So we'll use the work energy theorem. We know that by work energy theorem, the total work, that is work done due to gravity plus work done due to resistive force of the air, is equal to change in kinetic energy. Okay, and work done due to gravity is equal to 10 joule, we have just calculated, plus work done due to resistive force of the air, that we have to calculate, is equal to change in kinetic energy, that is half into m into v square, right? So if we put this value of mass and velocity, it will be half into, mass is 10 to the power minus 3 kg, right? Velocity or the speed is 50 meter per second. So the square of velocity will be 2500, right? Now it can be written as 1250. So 10 joule plus the work done due to resistive force will be equal to 1250 into 10 to the power minus 3. So that will be equal to 1.250, right? So work done due to resistive force will be equal to 1.250 minus 10 joule. So now we are subtracting a higher value from a lower value. So we'll get minus 8.75 joule. Okay. So this is a negative work, minus 8.75 joule. And here we can confirm that option C is the correct answer. Okay. Now question number 5 is from the chapter Units and Dimension, and the question is a physical quantity of the dimension of length that can be formed out of c, g and e square upon 4 pi epsilon naught is. Okay, so we have to find that physical quantity whose dimension is same as the dimension of length. That means it will have the dimension m0, l1, t0. Okay, and it can be formed out of c, g and e square upon 4 pi epsilon naught. That means that quantity can be related with some power of c, some power of g and some power of e square upon 4 pi epsilon naught. Okay, so let's say the power on c will be x, the power on g will be y, and the power on e square upon 4 pi epsilon naught will be z. Okay, now what will be the dimension of c? C is the velocity of light, so it will have the dimension m0 lt minus 1. Okay, this is the dimension of velocity of light. Now second one is g, that is gravitational constant. So let's see, we know that the gravitational force Fg is equal to G into m1 m2 upon r square. So G will be equal to F r square upon m1 into m2. So what will be the dimension of G? It will be equal to dimension of force, that is mlt minus 2, into dimension of r squared, that is L2, upon dimension of m1 m2, that is m square. Okay, so it will be m minus 1 L 3 and t minus 2. Okay, so this is the dimension of G. So let's write it down here, m minus 1 L 3 t minus 2. Similarly, we'll write the dimension of E square upon 4 pi epsilon naught. So this we can find using the formula for electrostatic force. We know that electrostatic force is equal to K into Q1 Q2 upon R square. Okay, so F into R square will be equal to K Q1 Q2. Okay, and in this question it is given that E is the charge. So in place of Q we can write E. Okay, and k is equal to 1 by 4 pi epsilon naught, so it can be written as E square upon 4 pi epsilon naught. Okay, that will have the dimension same as the dimension of f into r square. So f is equal to m l t minus 2 and r square is l2. Okay, so the dimension of E square upon 4 pi epsilon naught will be what? M l3 t minus 2. Okay, so let's write it down here, m l3 t minus 2. Now we'll use these dimensions. So it is given that this quantity that has the dimension same as dimension of length, that means M0 L1 T0 can be formed from C, G and E square upon 4 pi epsilon naught, right? And C will have the power x as we have assumed, G will be having the power y, and E square upon 4 pi epsilon naught will be having the power z. Okay, this is our assumption. What is the dimension of C? It is M0 LT minus 1. So let's write LT minus 1 only. Okay, it will have the power x. G is M minus 1 L3 T minus 2. Now it will have the power y, and E square upon 4 pi epsilon naught has the dimension M L3 T minus 2 and it will have the power z. Now let's open the bracket. It will be L to the power x, then T to the power minus x. Then opening the second bracket, it will be M to the power minus y, then L to the power 3y, then T to the power minus 2y, right? Now opening the third bracket, M to the power z, then L to the power 3z and T to the power minus 2z. Okay, now let's bring all the powers of M, L and T together. Okay, first M. So M has the power minus y and z. So minus y plus z. Okay, then L has the power, this side we have 3y, this side we have x and this side we have 3z. So let's add them, x plus 3y plus 3z. Okay, and the power of T, it has minus x, then minus 2y, then minus 2z. Okay, so minus x minus 2y minus 2z. And on the left hand side we had m to the power 0, L to the power 1 and T to the power 0. Now the total power on m will be same on the left hand side and on the right hand side. Similarly, on the total powers on L as well as T will also be same on the left hand side as well as right hand side. Okay, so we'll equate these. So for m, the power on the right hand side is what? Minus y plus z, and on the left hand side it is 0. So let's say this is equation number 1. Now for L on the right hand side we have the power x plus 3y plus 3z, and on the left hand side we have 1. So this is equation number 2. Similarly for T, the power on the right hand side is minus x minus 2y minus 2z, and on the left hand side it is 0. So let's say this is equation number 3. Now using these three equations, we'll find the values of x, y and z. So the first equation is what? Minus y plus z is equal to 0. So from here we can simply say that z is equal to y, right? That means whatever is the value of y, the same is the value of z. Okay. Now let's put the value of y or z in equation number 2. Okay. Equation number 2 is x plus 3y plus 3z equals to 1. Okay. So if we write x plus 3y plus 3y equals to 1, is there any issue? No, because z is equal to y. So in place of z we can write y, right? So x plus 6y equals to 1. So what will be the value of x? It will be 1 minus 6y. Now in the third equation, we can write all in terms of y only, because we know that z is equal to y. So in place of z, we'll write y. Also x is equal to 1 minus 6y. So we can write x also in terms of y, right? So our equation number 3 is minus x minus 2y minus 2z equals to 0. Now x is 1 minus 6y. So it can be written as minus 1 minus 6y minus 2y, again minus 2y because z is also equal to y, equals to 0. Now let's solve this. We'll find the value of y here, right? It will be minus 1 plus 6y minus 2y equals to 0. Okay. So minus 1 plus 6y, here we'll get plus minus 4, right? Minus 4y equals to 0. So we can say minus 1 plus 2y equals to 0. Okay. So 2y equals to 1, or we can write y equals to half. So now we have obtained the value of y. It is half, and we know that the value of z and y are same. That means z is also equal to half. Okay. So what will be the value of x? We know that x is equal to 1 minus 6y. That means 1 minus 6 into half. That is 1 minus 3. So it will be minus 2. So the value of x is minus 2. The value of y is half, and the value of z is also half. Let's write it down here. X equals to minus 2, y equals to half, and z is also equal to half. Okay. Now we can easily find that quantity which was asked in that question. So that quantity had some power c, some power of g, and some power of e square upon 4 pi epsilon naught, right? And c had the power x. So x is equal to minus 2. G had the power y, so it is equal to half, and e square upon 4 pi epsilon naught had the power y again, z, so z is equal to y only, so it will be half. Now both g as well as e square upon 4 pi epsilon naught have the power half, so it can be written together, these two can be written together, and c has the power minus 2, so it can be written as 1 upon c square, right? And here we can write g and e square upon 4 pi epsilon naught together as this, g e square upon 4 pi epsilon naught to the power half. Okay, we have taken the power common. So the correct answer will be 1 upon c square into g into e square upon 4 pi epsilon naught to the power half. So let's see which option is the correct one. In the last option, can you see 1 upon c square? That means c to the power minus 2, right? And g and e square upon 4 pi epsilon naught both had the power half. So this has been taken as common. Therefore, option D will be the correct answer. So this is quite lengthy, but if you solve it carefully, you'll easily solve it. Okay. Now question number 6 is from the chapter Thermal Properties of Matter, and the question is, two rods A and B of different materials are welded together as shown in figure. Their thermal conductivities are K1 and K2. The thermal conductivity of the composite rod will be. Okay. So here we can see that these two rods are in parallel combination. Okay. So they are in parallel combination. Now we can relate this situation with the parallel combination of resistances, right? This is how resistances are combined parallelly. So we know that in case of parallel combination, the reciprocal of equivalent resistance, that is 1 upon R equivalent, is the sum of reciprocals of individual resistances. Okay, 1 by R1 plus 1 by R2. Now we know that resistance is equal to rho L upon A, right? Rho is the resistivity. So we can write L upon Ka because resistivity is the reciprocal of conductivity. Okay. So in this question, conductivities are mentioned, not resistivities. So we'll write in terms of conductivity. Okay. So this is the value of R. So what will be the value of 1 upon R? It will be Ka upon L. Okay. So we can use this expression in this parallel combination formula. Okay. 1 upon R equivalent will be equal to K equivalent into 2A upon L, because the area will be doubled when they are joined like this, right? So the combined area will be doubled. Now individually it will be K1A upon L plus K2A upon L, right? Now L will be cancelled because it is on both the sides. Then area will also be cancelled. So what is left here? 2K equivalent equals to K1 plus K2. So what is the value of equivalent K of the combined this composite rod? It will be K1 plus K2 upon 2. Okay. So the conductivity of the composite rod will be K1 plus K2 upon 2. That is option D will be the correct answer. Question number 7 is from the chapter Electrostatic Potential and Capacitance. And the question is, a capacitor is charged by a battery. The battery is removed and another identical uncharged capacitor is connected in parallel. The total electrostatic energy of the resulting system, options are, decreases by a factor of 2, remains the same, increases by a factor of 2, or increases by a factor of 4. Okay, so see, what will be the initial electrostatic energy? The initial electrostatic energy will be equal to half CV square. This is the formula for electrostatic energy, right? Now, after the battery is removed and an uncharged capacitor is connected in parallel, we know that in case of parallel combination, the equivalent capacitance is the sum of individual capacitance, that is C1 plus C2. Okay, this is opposite to the case of resistances. In case of resistance, we find the sum in series combination, but in capacitance, we find the sum in parallel combination. Okay, now this is the identical capacitor, that means both are equal. So C plus C, that is 2C. Okay, so the equivalent capacitance of the parallelly combined capacitances will be 2C, right? And what will be the new potential difference? It will be V dash will be halved. Okay, so the new potential difference will be half of the initial potential difference. So the final electrostatic energy will be equal to half into 2C and V by 2 square. Okay, so let's solve this. This 2 will be cancelled. Then CV square upon 4. Okay, and we know that half CV square is the initial energy, so we can write it as half CV square, right? That means this is the half of initial electrostatic energy, right? That means it decreases by a factor of 2. Okay, so option A will be the correct answer. Question number 8 is from the chapter Semiconductor Electronics, and the question is, in a common emitter transistor amplifier, the audio signal across the collector is 3 volt. The resistance of the collector is 3 kilo ohm. If current gain is 100 and the base resistance is 2 kilo ohm, then the voltage and power gain of the amplifier is. Okay, so here current gain, that is beta, is given as 100, right? And the load resistance, that is the resistance of the collector, is 3 kilo ohm. And what is the input resistance? Input resistance is the resistance of the base, that is 2 kilo ohm, right? Now we can easily find the voltage gain using simple formula. So voltage gain is equal to current gain, that is beta, into load resistance upon input resistance. Okay, so beta is given as 100, load resistance is 3 kilo ohm, and the input resistance is 2 kilo ohm. Okay, so on solving this we get 150, right? Now voltage is 150, so it is quite clear that option B will be the correct answer, because it is the only option where voltage gain is 150. But still we'll find the power gain as well. So again a simple formula, power gain is equal to current gain into voltage gain. Okay. So current gain was 100 and voltage gain we have calculated as 150. So what do we get? We get 15,000. Okay. So now it's confirmed that option B is the correct answer. Question number 9 is from the chapter Thermodynamics, and the question is, thermodynamics processes are indicated in the following diagram. So this is the diagram, and then we have to match the column 1 with column 2. Okay, so let's see, we'll draw the graph again because this figure is quite confusing. So this side we have volume and this side we have pressure. So this is pressure versus volume graph. Now here 4 types of graphs are shown. So let me consider the easier ones first. This horizontal one is graph number 4 and this vertical one is graph number 1. Okay. So we know that in the graph number 1, volume is constant. Okay. So what type of process is this? Isochoric process. Okay. So in case of isochoric, what happens? Volume remains constant. So graph number 1, that is process 1, or we can say P, will be matched with C, that is isochoric. Okay, so P will be matched with C. That means either option A or B can be the correct answer. Now graph number 4, here we can see that pressure is constant. So it is an isobaric graph. Okay, isobaric means pressure is constant. Okay, so process 4, that is S, will be matched with B. Okay, so S will be matched with B. That means option A will be the correct answer, but still we'll consider other graphs as well. So here three curves are shown here, so don't confuse. We'll ignore the upper one, uppermost, because it is not of our importance. So we'll draw only two graphs here, graph number 2 and graph number 3. Okay, the lower one is graph number 2 and the upper one is graph number 3. Okay, so out of these two, which one will be adiabatic and which one will be isothermal? We know that the one having more slope will be the adiabatic. Okay, so second one has steeper slope, so it will be adiabatic, and whatever is left, that is isothermal. Okay, so the second one, that is Q, will be matched with first one, that is adiabatic. Okay, so Q will be matched with A, and therefore R will be matched with the remaining, that is D. Okay, therefore option A will be the correct answer. Next question is related to electrostats as well as gravitation. Okay, and the question is, suppose the charge of a proton and an electron differ slightly. One of them is minus E and the other is E plus delta E. If the net of electrostatic force and gravitational force between two hydrogen atoms placed at a distance d apart is 0, then the delta E is of the order of, okay, mass of hydrogen is mentioned. Now, first of all, we know that a hydrogen atom consists of an electron and a proton, right? So the net charge on the hydrogen atom will be the charge on electron plus charge on proton. So it is given that one of them has charge minus E and the other has E plus delta E. Okay, so let's say the electron has charge minus E and the proton has charge E plus delta E. So on solving this, we get minus E plus delta E. So minus E plus E will be 0. That means delta E will be the charge on hydrogen atom. Okay. And two such hydrogen atoms are there according to this question, which are placed at a distance d apart. Okay. And we know that the charge on each hydrogen atom will be delta E. Now, the most important line of this question is that the net of electrostatic force and gravitational force between two hydrogen atoms placed at a distance d apart is 0. That means the difference of electrostatic force and gravitational force will be 0. So, electrostatic force minus gravitational force or gravitational force minus electrostatic force will be 0. And what does this imply? It implies that the electrostatic force will be equal to the gravitational force, right? So let's find the electrostatic force and gravitational force and then we'll equate them. So the electrostatic force will be equal to K Q1 Q2 upon R square. This is the formula for electrostatic force. So if we put the values, K will be written as it is. Then charge on each hydrogen is delta E. So we can write delta E square. R is the distance between them. So here D is the distance. So we can write D square. Let's say this is equation number 1. Similarly, gravitational force is equal to G m1 m2 upon R square. So G into, and mass of both the hydrogen atoms will be same. So we'll write m square upon D square again. Okay. Let's say this is equation number 2. And we know that these two forces are equal. So electrostatic force is equal to the gravitational force. That means K into delta E square upon D square is equal to G into M square upon D square, right? So D square cancelled. So delta E square will be equal to Gm square upon K, or we can write delta E is equal to under root Gm square upon K. Now we have to find the order of delta E, right? So we'll put the values here. What is the value of G? That is gravitational constant. It is 6.67 into 10 to the power minus 11. Mass of hydrogen is given. So 1.67 into 10 to the power minus 27 square. Okay. Square of mass is there. Then what is the value of k? This is the constant 9 into 10 to the power 9. Okay. Now, if you look at the options, you can see that only some power on 10 is given. That means we don't have to calculate this completely. We just have to find what power of 10 will be there. Okay. So in that way, we can find the order of delta E. Okay. So let's focus on 10 to the power something. So here in this, where we have to find the m square, here you can see 10 to the power minus 27 is there and then square is there. Okay. That means double of 27 minus 27, it will be minus 54. Okay. So here we'll write the powers only. Okay. Powers of 10 only. 10 to the power minus 11 is here into, if we solve this, we'll get 10 to the power minus 54. And on the denominator side, we have 10 to the power 9. Now 10 to the power minus 11 minus 10 to the power minus 54 will be what? It will be 10 to the power minus 65. And then here we have 9. So minus 9. What do we get? We get under root 10 to the power minus 74. Okay. If we have to find the root, we'll just find the half of 74. Okay. So it will be 10 to the power minus 37. Okay. This will be the order of delta E. That means which option will be the correct answer? Option B will be the correct answer. 10 to the power minus 37 coulomb. Question number 11 is from the chapter Current Electricity, and the question is the resistance of a wire is R ohm. If it is melted and stretched to n times its original length, its new resistance will be. Okay, so that means we have to find the relation between the resistance and the length, right? Now what will happen if this is melted and stretched to n times? The length will increase, right? Length will increase. What will happen to area? Area will decrease. But one quantity will remain constant, that is the volume. Okay, so volume will remain same. Now we know that resistance is equal to rho, that is resistivity, into L upon A. Length, L is the length and A is the area. So we have to find the relation between resistance and length, but here area is also given, and in this case the area will also change. So let's make this constant by converting it into volume. So if we multiply and divide this side by L, what do we get? We'll get rho into L square upon area into length, that is volume. Okay. So now we can say that resistivity is constant, volume is constant. That means resistance is directly proportional to the square of length, right? So the ratio of the resistances, that is R dash and initial resistance R, will be equal to the new length L dash by initial length square. Okay, because resistance is proportional to L square. So R dash upon R will be equal to new length will be what? N times the original length. So it will be N into L upon initial N into square. Square of this. Okay. So length cancel. That will be equal to N square. That means the new resistance will be N square times the initial resistance. So the option number B will be the correct answer. Question number 12 is from the chapter Semiconductor Electronics, and the question is the given electrical network is equivalent to. Okay, so here we have to keep in mind few things. We know that in case of OR gate, what do? We put a plus sign between two inputs. Suppose A and B are two inputs. So in case of OR gate, a plus sign will be put here. So A plus B will be the output. Similarly, in case of AND gate, what do? We put a dot. So A dot B will be the output. In case of NOT, we put a bar. Okay, we put a bar over something. Let's say this is A or B, so we put a bar. And now the NOR gate and NAND gate. NOR is the combination of NOT and OR. So we have to write OR, that means A plus B, and put a bar on it in case of NOR gate. And in case of NAND gate, what do? A dot B, that means and NOT, bar for NOT. Okay, so you have to remember these things. Now let's start solving this question. Here we have three gates. This is gate 1, that is NOR gate. Okay, this is OR plus NOT. Small bubble is NOT. So this is NOR gate. Second one is also NOR gate. And the last one is NOT gate. Right. Now, Inputs are A and B, and first it is passing through the NOR gate, so it will be what? A plus B bar. This is the first output. Now in the second one you can see that these two inputs are combined. Okay, this shows that this will behave as a NOT gate. This NOR gate will behave as a NOT gate. You have to remember that whenever the inputs are combined, then the universal gate behaves as a NOT gate. Okay, so when this passes through the NOT gate, what happens? It will be equal to A plus B double bar. Okay, just one more bar because of NOT gate. Now this is equal to A plus B only. This is the rule that when two bars are there, then it will be equal to A plus B only. Okay, that means both the bars are cancelled. Now the last one is NOT gate. So this will pass through the NOT gate. A plus B will pass through the NOT gate again. And what will happen? Just a bar will come. So A plus B bar, this will be the final output. Okay, this is the final output. It is A plus B bar, and A plus B bar is the output of NOR gate. Therefore, option B will be the correct answer. Now, question number 13 is related to photoelectric effect, and the question is the de Broglie wavelength of a neutron in thermal equilibrium with heavy water at a temperature T Kelvin and mass m is. Okay, so we know that the de Broglie wavelength lambda is equal to h upon mv. Mv is momentum, right? That means h by p. We can write p. So p is momentum. Now we know that kinetic energy is equal to p square upon 2m. Okay, where p is the momentum. So in terms of kinetic energy, what will be the value of momentum? It will be 2mk and root of this. Okay, under root 2mk. So in place of momentum, we can write this. So it will be h upon under root 2mk. Now we know that the kinetic energy of a neutron in thermal equilibrium is equal to 3 by 2 kT. Okay, if you know the theory, then you will understand why it is 3 by 2 kT. Now here, if we put 3 by 2 kT, this value in this kinetic energy, then what do we get? Let's see. H upon under root 2m into 3 by 2 kT. So 2 and 2 cancelled. Here we'll get h upon under root 3m kT. Therefore, this will be the de Broglie wavelength of that neutron. Therefore, option A will be the correct answer, h upon under root 3m kT. Question number 14 is from semiconductor electronics, and the question is which of the following represents forward bias diode? So here we have to use the simple concept that in case of forward bias, V1 is greater than V2. Okay, so this side we have V1, this side we have V2. Now in the first one, V1 is -4 and V2 is -3. So which one is greater? V2 is greater, right? So this will not be the forward bias. In second case, we have -2, V1 is -2 and V2 is +2. Again, V2 is greater. Okay, so this is also not forward bias. In the third one, this side we have 3 volt, this side we have 5 volt. So 5 volt is greater. Again, V2 is greater. In the last one, this side we have 0, this side we have -2. So which one is greater? This one. So in this case, V1 is greater than V2. Therefore, option D will be the correct answer. This is the case of forward bias diode. Now, question number 15 is from the chapter electromagnetic induction. And the question is, a long solenoid of diameter 0.1 meter has 2 into 10 to the power 4 turns per meter. At the center of the solenoid, a coil of 100 turns and radius 0.01 meter is placed with its axis coinciding with the solenoid axis. The current in the solenoid reduces at a constant rate to 0 ampere from 4 ampere in 0.05 seconds. If the resistance of the coil is 10 pi square ohm, then the total charge flowing through the coil during this time is. Okay, so let's understand the question. We have a long coil or solenoid. Okay, and inside this we have a smaller coil that is placed at the center. Now, let's say that the radius of the coil, radius of the solenoid, the bigger one is R1, and the radius of the coil that is placed inside this is R2. Okay. Similarly, the number of turns for the bigger one is N1, and the number of turns for the smaller coil is N2. So let's write the values of R1, R2, N1 and N2. For the bigger one, that is the first sentence of this question, it is written that the long solenoid has diameter 0.1 meter, so its radius will be 0.1 by 2, that is 0.05 meter. Okay, and the number of turns, that is N1, will be 2 into 10 to the power 4. Now for the smaller coil, the radius is given as 0.01 meter and number of turns is given as 100. What else is given? It is given that the current changes from 4 ampere to 0 ampere in 0.05 seconds. So di by dt, that is rate of change of current, will be equal to 4 minus 0 by 0.05 second. So here we'll get 80 ampere per second. Okay, this is the change in rate of change of current. What else is mentioned? Resistance is mentioned. Let's say capital R is the resistance. So resistance is given as 10 pi square ohm. Now, we know that due to the current flowing in the bigger solenoid, magnetic field will develop in the smaller coil also. Okay, so flux, magnetic flux will also be there. So we can find out the EMF. We know that EMF, so here EMF is due to the mutual effect, right? So it will be equal to M di by dt. M is the mutual inductance. Now what is the formula for mutual inductance? It is equal to mu naught N1 N2 into A2. A2 is the area of the smaller coil, right? Upon length. Now length is not mentioned, so we'll take it as 1 meter only. So let's put the values here. Mu naught is equal to 4 pi into 10 to the power minus 7. This is a constant. N1 is equal to 2 into 10 to the power 4. N2 is equal to 100. And area will be equal to pi r square. R, that means the radius of the smaller one, that is 0.01 meter. So 0.01 square upon length is 1 only, so let's just ignore it. Now on solving this, what do we get? We'll get 8 pi square into 10 to the power minus 5. Okay, now we'll put this value of m in this formula for EMF. So we'll write 8 pi square into 10 to the power minus 5, and now into di by dt. Di by dt is equal to 80 ampere per second. We have already calculated here. So 80 ampere per second. Now on solving this, we'll get 640 pi square into 10 to the power minus 5. So what is this? This is the EMF. Now we'll find the current. So the current I is equal to EMF divided by resistance, isn't it? So EMF is 640 pi square into 10 to the power minus 5, and resistance is given as 10 pi square ohm. So pi square cancelled. 10 will be this 0 cancelled. So here we get 64 into 10 to the power minus 5. Now this is the current, but in this question we have to find the total charge flowing. So with the help of current we can find out the charge also. Charge, that is Q, is equal to I delta T. I is the current, that is 64 into 10 to the power minus 5. Delta T, the change in time, is 0.05 seconds. So on solving this, we get 32 into 10 to the power minus 6 coulomb. And minus 6, 10 to the power minus 6 means microcoulomb. Okay, so it can be written as 32 microcoulomb. So the final answer will be 32 microcoulomb. That means option B will be the correct answer. Question number 16 is from the chapter Motion in One Dimension, and the question is, Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time t1. On other days, if she remains stationary on the moving escalator, then the escalator takes her up in time t2. The time taken by her to walk up on the moving escalator will be. Okay, so basically two cases are mentioned here. Okay, let's say this is case 1, this is case 2. And let's assume that the height of the floor is h. Okay, height of the floor is h. Now in first case, it is seen that the escalator was not working. Okay, so escalator was not in motion, only Preeti was moving on the stationary escalator. So in this case only Preeti is moving, right? Only Preeti is moving. And what is the time taken by Preeti to move up the stairs? The time is t1, right? So this t1 is the time taken by Preeti. So what will be the velocity of Preeti? Velocity of Preeti, or you can say Preeti's walking speed, is equal to the total height of the floor upon the time taken by Preeti, okay, t1. So h upon t1 is velocity of Preeti, that is v1, right? Now in the second case, Preeti remains stationary on the moving escalator. That means in this case only escalator is moving. Only escalator is moving and the time is t2. Time t2. So what will be the velocity of escalator? The total height of the floor upon the time taken by escalator t2. Okay, so this is v2. V2 is equal to h upon t2. Now in the third case, when both will be moving, that means the stationary, the escalator is also moving and the Preeti is also moving up. Okay, so in that case the total velocity, combined velocity will be what? Combined velocity will be v1 plus v2, right? And height will remain same. Height will remain same. So what will be the combined time? The total time taken in this case, it will be equal to total height, that is h, upon total speed, that is v1 plus v2. Now in order to get a common denominator, we can find 1 by t first. Okay, 1 by t combined will be equal to v1 plus v2 upon h. So we can write it as v1 upon h plus v2 upon h, right? Now let's put the values of v1 and v2 that we had seen. Okay, so 1 by t combined is equal to v1 upon h. So v1 is equal to h upon t1, right? So h upon t1, and here there is h also. Now plus v2 upon h. So v2 is h upon t2, h upon t2, and then h is there. So h will be cancelled. So it will be 1 upon t1 plus 1 upon t2. So this is 1 by t combined, that is t1 t2, and here we have t2 plus t1. Okay, so what will be the t combined? The total time will be inverse of this, that is t1 t2 upon t1 plus t2. That means option B will be the correct answer. Question number 17 is from the chapter Wave Optics, and the question is, Young's double slit experiment is first performed in air and then in a medium other than air. It is found that eighth bright fringe of the medium lies where fifth dark fringe lies in air. The refractive index of the medium is nearly. Okay, so we know that whenever medium is changed, wavelength or lambda also changes. Okay, that means if lambda is the wavelength in air, then the lambda in a medium will be equal to lambda in air divided by the refractive index of the medium. Okay, so here we have to find this refractive index in this question, the value of refractive index. Now it is said in this question that eighth bright fringe in the medium lies where fifth dark fringe lies in air. So first we'll talk about the bright fringe. We know that when we are talking about the bright fringe, that means we are talking about maxima. Okay, maxima, and that is equal to n beta. Okay, maxima is equal to n beta. So since we are talking about the eighth bright fringe here, that means we are talking about the eighth maxima. So n will be equal to 8, so it will be equal to 8 beta. And also we know that beta is equal to lambda into capital D by small d, right? So this is for air, but for medium, for medium, we know that lambda will become lambda by refractive index. So beta will become lambda d by mu d. Okay, for medium. So in first case, we are talking about 8th bright fringe in the medium, right? So it will be equal to 8 lambda d by mu d. So this is the first one. Now, second case is 5th dark fringe lies in air. So when we are talking about the dark fringe, that means we are talking about the minima. And minima is equal to 2n minus 1 beta by 2. Okay. So here we are talking about the 5th dark fringe. That means we are talking about the 5th minima. So it will be equal to 2 into 5 minus 1 beta by 2. Right. So what do we get here? We'll get 9 beta by 2. So again we'll put the value of beta as lambda d by d. Now this is in air, not in medium. So it will be simply 9 by 2 lambda d by small d. Okay, this is the second one. And both lie in the same region. Okay, 8th bright fringe in the medium, that means this first one, and the 5th dark fringe in air, that means the second one, lie in the same medium. So according to the question, 8 lambda d by mu d will be equal to 9 by 2 lambda d by d. Okay, and we have to find the value of mu, that is refractive index. Okay, now lambda cancel, capital D cancelled, small d also. So what do we get here? Here we get 16 by 9 equals to mu. So the value of mu will be 16 divided by 9. So the approximate value will be 1.78. Therefore, which option will be the correct answer? Option number C. 1.78 will be the value of mu. Now question number 18 is from the chapter Ray Optics and Optical Instruments, and the question is, a beam of light from a source L is incident normally on a plane mirror fixed at a certain distance x from the source. The beam is reflected back as a spot on a scale placed just above the source L. When the mirror is rotated through a small angle q, then the spot of the light is found to move through a distance y on the scale. The angle q is given by. Okay, so let's understand the question. Here we have a source of light. Okay, and according to this question, at a certain distance x from this source, let's say this is the distance x, a plane mirror is placed. So this is the plane mirror. Plane mirror. Now, two cases are mentioned here. In first case, when the light is incident on this plane mirror, it is reflected back on the same path. Okay, because the light was incident normally in this case. And how do we know this? Because the spot of light is just above the source L. Okay, so this is the source L, and just above this a spot of light was found. Let's say P is the spot. So in this case we can understand that the light has been reflected back. But in another case, when this mirror is rotated through a small angle Q, okay, then what happens? This spot of light is found to move through a distance y on the scale. Okay, so this side we have a scale. We have scale on this side. That means on the side of the source. So in the second case, when the mirror is rotated through this angle q, then this spot of light moves at a certain distance. Suppose it moves here. Okay, and this is distance y from the source. So now we have to find the angle q. Okay, so how do we know this? See, let's join this first. The light has been reflected towards this direction, right? Now, if we look at this triangle, this shaded portion, here, first we should remember that when the plane mirror is rotated by an angle theta, then the reflected ray will be rotated or is rotated through double that angle. That means 2 theta. Okay, so this is the rule that you have to remember, that if we rotate this plane mirror through an angle theta, then what happens? The reflected ray will be rotated through angle 2 theta. Okay, so this angle of this triangle will be equal to what? 2q, because the mirror was rotated through the angle q. Okay, now we have to find what is that angle q. So in this triangle you can understand that this angle 2q will be equal to this height, that is y, divided by this distance x. Okay, so what will be the value of q? It will be equal to y upon 2x. So which option will be the correct one? Option D will be the correct answer. Question number 19 is from the chapter Magnetism and Matter, and the question is, if theta 1 and theta 2 be the apparent angles of dip observed in two vertical planes at right angles to each other, then the true angle of dip theta is given by. Okay, so first of all, what is angle of dip? It is the angle that is formed between the total field vector and the horizontal plane. Okay, the horizontal plane. We know that the magnetic field has two types of components, the horizontal component, that is BH, and the vertical component, that is BV, right? And this is the total field vector, say B. Now the angle that this total field vector B forms with respect to the horizontal is known as angle of dip. So this angle theta is the angle of dip that has to be determined in this question. Okay. Now another important thing to know, that the horizontal component BH is equal to B cos theta, and the vertical component BV is equal to B sin theta, and the ratio of vertical and horizontal components is equal to tan theta. Okay, that means tan theta is equal to BV by BH. So this is the basic of this. Okay, this is the basic concept. Now we'll come back to the question. In this question, it is said that there are two vertical planes at right angles to each other. So what does this mean? Two vertical planes are there. Two vertical planes. That means they will have the same vertical component. Okay, so vertical component will remain same. Vertical component will be same for both, but the horizontal components will vary. So let's say this is your first plane, this is plane 1, and this is a plane 2. These are at some angle. Okay, and this is the vertical component BV that will be same for both, but the horizontal components will be different for both. Okay, so this is BH1, the horizontal component for plane 1, and this side we have BH2, the horizontal component for plane 2. Okay, so let's assume that the angle between the magnetic meridian and one of the planes is phi. Okay, so let's assume that the angle between magnetic meridian and one of the planes, say plane 1, is equal to phi. Then what will be the angle between the magnetic meridian and another plane? So angle between the magnetic meridian and plane 2 will be equal to 90 minus phi. Why? Because both the planes are at right angles to each other. Okay, since both are at right angles to each other, so the other angle will be 90 minus phi. Now for plane 1, now we are starting to solve the question. For plane 1, tan theta 1 will be equal to the vertical component, that is BV, divided by the horizontal component, that is BH cos phi. And we know that BV by BH is equal to tan theta, isn't it? This is equal to tan theta. So it can be written as tan theta divided by cos phi. So you have to pay attention to this, otherwise you'll get confused. So what did we get? We got that tan theta 1 is equal to tan theta by cos phi. So what will be the value of cos phi here? Cos phi will be equal to tan theta divided by tan theta 1. Right? Let's say this is the first equation. Now for the second plane, for plane 2. For plane 2, we'll find tan theta 2. Okay. So tan theta 2 will be equal to vertical component, that will remain same. So we have seen that the vertical component remains same, divided by the horizontal component. So the horizontal component for the second plane will be what? BH cos 90 minus phi. Right? We have already seen y. So this can be written as BV by BH sin phi. Okay. Because cos 90 minus phi will be equal to sin phi. So what did we get here? We got tan theta 2 equals to, this BV by BH can be written as tan theta, right? So tan theta upon sin phi. So this means that the value of sin phi will be equal to tan theta divided by tan theta 2. So let's say this is equation number 2. Okay, so let me highlight these. We have got the value of cos phi and sin phi right now. Now we have to simplify this. So we know that sin square phi plus cos square phi will be equal to 1, right? So if we put the values of sin phi and cos phi, let's do this. Sin phi is equal to tan theta by tan theta 2. So sin square phi will be equal to tan square theta by tan square theta 2, and cos square phi will be equal to tan square theta divided by tan square theta 1. So that will be equal to 1 only. Okay. Another important thing here. Now we just have to simplify these things. Okay, because this is not given in answer. So we'll simplify this. So how can we do this? Let's take tan square theta common. Okay. So taking tan square theta common, here we get 1 by tan square theta 2 plus this side we have 1 by tan square theta 1, that will be equal to 1. Now if we divide both sides by tan square theta, just to cancel this tan square theta. Okay, so on dividing both sides by tan square theta, we get, let's do it, tan square theta divided by tan square theta, and this side we have 1 by tan square theta 2 plus 1 by tan square theta 1. On the right hand side also we'll divide by tan square theta. So let's solve this. This side it will be cancelled. So what will be left on the left side? Only 1 by tan square theta 2 plus 1 by tan square theta 1. And this side we get 1 by tan square theta, that means cot square theta. So 1 by tan square theta 2 can be written as cot square theta 2 plus 1 by tan square theta 1 can be written as cot square theta 1. So that will be equal to cot square theta. So this will be the correct expression. So let's see which option should be correct. It should be that cot square theta is equal to cot square theta 1 plus cot square theta 2. Okay. So the correct option will be option number D. Okay. This will be equal to sign cot square theta, that is equal to cot square theta 1 plus cot square theta 2. Okay. So this is the correct answer. Alright, now question number 20 is from the topic Doppler's effect of chapter waves, and the question is, two cars moving in opposite directions approach each other with a speed of 22 meter per second and 16.5 meter per second respectively. The driver of the first car blows a horn having a frequency of 400 Hz. The frequency heard by the driver of the second car is, okay, the velocity of sound is given as 340 meter per second. Now, driver of which car blows the horn? First car. And the first car has velocity 22 meter per second. That means this is the velocity of the source. Okay. So in this question, the velocity of source is equal to 22 meter per second. And the velocity of the observer or the listener, you can say, is 16.5 meter per second, because we have to find the frequency that is heard by the driver of the second car. So we know that the apparent frequency is equal to the frequency of the source into velocity of sound plus velocity of the observer divided by velocity of sound minus velocity of the source. So this is a simple formula based question. Let's put the values. The frequency of the source is 400 Hz. Velocity of sound is 340 meter per second plus velocity of observer is 16.5 meter per second divided by velocity of sound, again 340, minus the velocity of source, that is 22 meter per second. So on solving this, you'll get 448 Hz. So this is the apparent frequency. Therefore, this frequency will be heard by the driver of the second car. Therefore, which option will be the correct one? Option C will be the correct answer. Question number 21 is from the chapter Laws of Motion, and the question is, two blocks A and B of masses 3m and m respectively are connected by a massless and inextensible string. The whole system is suspended by a massless spring as shown in the figure. The magnitudes of acceleration of A and B immediately after the string is cut are. Okay. So it is said that if this string is cut, then what will be the acceleration immediately after that for these two blocks A and B. Okay, so we'll find the answer using the free body diagram. Okay, it will help us in better understanding. So free body diagram, first we'll see what happens before cutting the string. Before cutting the string. So before the string is cut, let's say this is the lower block, that is block B. So what are the forces acting here? The downward force is the weight of this block, that is mg. Okay, and the upward force will be the tension in the string. So these are the forces before cutting the string, and we know that before cutting the string the system was in equilibrium. Okay, that means this is stable. So the downward force will be equal to the upward force, right? So we can say that in equilibrium, tension will be equal to mg. Okay, the downward and upward force will be equal. They will balance each other. So let's say this is equation number 1. Now if we look at the second block, that is block A, the upper block, right? What are the forces acting downward? So downward there is one tension in the string, okay, because the tension is there, the string is there below the block A, right? Plus the weight of this block, that is 3 mg, because the mass is 3m for this block. So this is the total downward force, and upward force for this block is the spring force, because spring is present above the block A. Okay, again in equilibrium we can say that these two forces will balance each other. That means the spring force will be equal to tension plus 3 mg. Okay, the upward force will be equal to the downward force, and in the first equation we have seen that T is equal to mg, so it can be written as mg in place of T plus 3 mg. That means it is equal to 4 mg. So we can say that the spring force will be equal to 4 mg. So let's mark it as equation number 2. Now this was the scenario before cutting the string. Now if we see what happens after cutting the string. So after cutting the string, what happens? Again we'll see the free body diagrams of each block. So this is the block B. Now the string is cut. Okay, the string was present above this block. So what happens? The tension becomes 0. Tension becomes 0. and the downward force will remain same, that is the weight of this body. So that is equal to mg. So what will be the net force? Net force will be equal to the downward force only, because the upward force is 0. Okay, and net force is mass into acceleration. So ma is equal to mg. That means acceleration for this block is equal to g. Okay, so this is one of the answers. That means for block B the acceleration is g. Now we have to find the acceleration of the block A. So here downward force was, we had seen that it was t plus 3 mg, right? But t has become 0. So 0 plus 3 mg, that means the downward force is equal to 3 mg only. But upward force, that is the spring force, will remain same, that is 4 mg. Okay, why does this remain same? Because the spring force is non-impulsive. Just note it down here. Spring force is non-impulsive. That means it remains there for a very long time. Okay, so although tension will vanish immediately after cutting the string, but spring force will not vanish, so it will remain same as it was before cutting the string. Okay, so again net force will be equal to what? This time upward and downward both forces are available, so net force will be equal to 4 mg minus 3 mg. Okay, net force is mass into acceleration, that means 3m, mass is 3m into acceleration will be equal to 4 mg minus 3 mg, that is mg. So mm cancelled. So this time what will be the value of A? It will be equal to g by 3. Okay, so this is the acceleration of the block A. So the block A has acceleration g by 3 and block B has acceleration g. So option A will be the correct answer. Now question number 22 is from the chapter Ray Optics and Optical Instruments, and the question is, a thin prism having refracting angle 10 degree is made of glass of refractive index 1.42. This prism is combined with another thin prism of glass of refractive index 1.7. This combination produces dispersion without deviation. Okay, so this is important. The refracting angle of the second prism should be. So let's note down what is given here. The refractive index of the first prism is given as 1.42. So mu1 is equal to 1.42. And the refractive index of the second prism, that is mu2, is given as 1.7. Right? Now, the refracting angle of the first prism, that means A1, is given as 10 degree. And we have to find the refracting angle of the second prism, that means A2 is to be determined here. Okay. Now, the most important line here is that the combination produces dispersion without deviation. That means delta 1 will be equal to delta 2. Okay. Now, what is the formula for delta? Delta is equal to mu minus 1 into A, where mu is the refractive index of the material and A is the refracting angle. Okay. This is the refracting angle. So let's write the formula for delta 1. It will be equal to mu1 minus 1 into A1, and for delta 2 it will be mu2 minus 1 into A2. So let's put the values. Mu1 is equal to 1.42 minus 1 into A1 is equal to 10 degree, right? Similarly, this side mu2 is equal to 1.7 minus 1 and A2 is unknown. We have to find the value of A2. 1.42 minus 1, that is 0.42 into 10 degree will be equal to 1.7 minus 1, that is 0.7 into A2. Now 0.42 into 10, that means 4.2. So 4.2 divided by 0.7 will be equal to A2, right? So decimal will be cancelled and 7 into 6 is 42. So that means A2 is equal to 6 degree. Okay. Therefore, which will be the correct option? Option A will be the correct answer. Question number 23 is from the chapter Gravitation, and the question is, the acceleration due to gravity at a height 1 kilometer above the earth is the same as at a depth d below the surface of the earth. Then we have to find the depth d. Okay. Now we know that the formula for acceleration due to gravity at some height, let's say at a height h, is equal to g, that is acceleration due to gravity on the surface, into 1 minus 2h upon r, where r is the radius of the earth. Okay. And what will be the value of g at some depth d? At the depth d, it will be equal to g into 1 minus d by r. Again, r is the radius of the earth and d is the depth. So here it is given that the acceleration due to gravity at the height h, that is gh, is equal to the acceleration due to gravity at the depth d. Okay, that means g into 1 minus 2h upon r is equal to g into 1 minus d upon r. Okay, so g is on both sides. So 1 minus 2h upon r is equal to 1 minus d upon r. Okay, again 1 cancel, minus sign cancel, r also cancelled. So 2h equals to d. That means d is equal to 2 times the height, right? And height is given as 1 kilometer. So d is equal to 2 into 1 kilometer, that is 2 kilometer. Okay, so correct option will be option number C, D is equal to 2 kilometer. Question number 24 is from the chapter Current Electricity, and the question is, a potentiometer is an accurate and versatile device to make electrical measurements of EMF because the method involves option A, potential gradients, option B, a condition of no current flow through the galvanometer, option C, a combination of cells, galvanometer and resistances, and the last one is cells. So this is a direct question and the correct answer will be option B, a condition of no current flow through the galvanometer. Okay, so the main point is that in case of zero deflection condition in galvanometer, the potentiometer draws no current, therefore it gives the accurate reading. Okay, so option B will be the correct answer. Now question number 25 is from the chapter Thermal Properties of Matter, and the question is, a spherical black body with a radius of 12 centimeter radiates 450 watt power at 500 Kelvin. If the radius were halved and the temperature doubled, then the power radiated in watt would be. Okay, so we know that according to the Stephen-Boltzmann law, Boltzmann law, the energy radiated by a black body is equal to sigma into A into T to the power 4. A is the area, T is the temperature. Okay. So we know that sigma is constant. That means the energy radiated is proportional to area and to the fourth power of temperature. Okay. Also we know that area of a spherical body is equal to 4 pi r square. Right. So in place of area we can write r square. Okay. Because 4 pi will also be constant. So energy will be proportional to the square of radius and fourth power of temperature, right? So E2 by E1 will be equal to R2 by R1 square into T2 by T1 to the power 4. Okay. Now it is given in this question that the radius were halved. That means R2 is half of the first radius R1. Okay. So in place of R2 we can write R1 by 2. So it is equal to R1 by 2, and here we have R1 square, and the temperature is doubled, so T2 is equal to 2T1. So in place of T2 we'll write 2T1, and here we have T1 to the power 4. So R1 cancel, T1 cancel, so here we get half square, here we get 2 to the power 4. So what do we get? Half square, that means 1 by 4, and 2 to the power 4, that means 16. So that is equal to 4. So that means E2 by E1 is equal to 4. So E2 will become 4 times E1. And E1 is given as, what is the value of E1? The energy radiated is 450 watt power. So 4 times this energy, that means 4 into 450 will be equal to 1800 watt. So this will be the power in second case. That means option C will be the correct answer. Now question number 26 is related to EMI, and the question is, figure shows a circuit that contains three identical resistors with resistance 9 ohm each, two identical inductors with inductance L equals to 2 millihenry each, and an ideal battery with EMF 18 volt. The current I through the battery just after the switch is closed is, okay. So we have to find the current. Now the question says just after the switch is closed, that means at t equals to 0. At t equals to 0, what happens? The inductor will offer infinite resistance, right? That means XL is equal to infinity. So no current will flow through the inductor. Okay, no current flows through the inductor. That means it will act as open circuit. Okay, so we have two inductors here, one here and one here. So both will be acting as open circuit. Okay, so these two inductors are of no use because no current is flowing through them. So since the current is not flowing through this inductor, the first one, so this resistance is also of no use because current is not going into this arm, right? Now next thing is capacitor. So what will happen to the capacitor at this moment? That means at t equals to 0, the case with capacitor is just the opposite of the inductor. That means that at this moment, at this moment, the resistance offered by the capacitor will be equal to 0. Okay, Xc will be equals to 0. That means in this case, current will be infinite. Okay, so infinite current flows, infinite current flows through the capacitor. Okay, just the opposite case. So what will happen to the capacitor? It will get short circuited. Okay, the capacitor will get short circuited due to excessive flow of current through it. That means this capacitor is also of no use. So now we can see that neither inductor nor capacitor has any use in this circuit. So the circuit becomes very simple. So let's draw the simplified form of this circuit. Here we have a battery, right? The first arm is useless because the current is not flowing through this. In the second arm we have a resistance. Then in the third arm also we have a resistance here. Okay, and below that no use because of the inductor and capacitor. So this is the simplified form of this circuit. Now you can see this circuit has two resistances which are in parallel. So what will be the equivalent resistance for these two parallel resistances? It will be R by 2. Okay, and resistance is given as 9 ohm. So 9 by 2 is the equivalent resistance, and EMF is given as 18 volt, right? So we have to find out the current. Current is equal to EMF divided by resistance. So EMF is 18 volt, resistance is 9 by 2, so 9 and 2 here. So it will become 4 ampere. Okay, so the current just after the switch is closed will be 4 ampere. So none will be the correct answer. That means option D will be the correct answer. I think in actual paper this option was not given and instead some other option was given. So bonus mark was given for this question. Okay. Alright, now question number 27 is from the chapter Nuclei. And the question is, radioactive material A has decay constant 8 lambda and material B has decay constant lambda. Initially they have the same number of nuclei. After what time the ratio of number of nuclei of material B to that of A becomes 1 by E. Okay. So we know that the number of nuclei n is given as n naught e to the power minus lambda into t, where n naught is the initial number of nuclei, lambda is the decay constant and t is the time. So here we have two materials, material A and material B. So if we write this for the material A, then Na will be equal to n naught e to the power minus 8 lambda t, because the decay constant for A is 8 lambda. Okay. Similarly, for material B, Nb will be equal to n naught into e to the power minus lambda t, because the decay constant is lambda for this material B. Okay. N naught will remain same because they have same number of nuclei initially. So what will be the ratio of Nb to Na? It will be equal to Nb is what? N naught e to the power minus lambda into t. Na is n naught e to the power minus 8 lambda into t. So n naught is same, so it will be cancelled, and it is given that this ratio nb to na becomes 1 by e. So we can write 1 by e here. It will be equal to e to the power minus lambda t minus minus 8 lambda t. That means e to the power minus lambda t plus 8 lambda t. And 1 by e means what? E to the power minus 1. Okay. And this side we get e to the power. On solving this we get 7 lambda t. Now they have the same base, that is e. So we can say that 7 lambda t equals to minus 1. Okay. We are relating the powers. So we have to find the time t. So t will be equal to minus 1 by 7 lambda. So we are getting a negative time which should not happen, but we have to find the most appropriate answer. So if we focus just on the magnitude, so it will be option A, 1 by 7 lambda should be the correct answer. Next question is from the chapter Electrostatic Potential and Capacitance, and the question is, the diagrams below show regions of equipotentials. A positive charge is moved from A to B in each diagram. So first option says in all the four cases the work done is the same. Second option says minimum work is required to move the charge Q in figure A. Then maximum work is required to move charge Q in figure B. And the last option says minimum work is required to move charge Q in figure C. So here if we look at all the four figures, you can see that delta V is same. Okay, delta V is same. And we know that work done is equal to charge into delta V. Delta V, that means change in potential. So when delta V is same, work done will also be same. That means first option will be the correct answer, that in all the four cases the work done is the same. So option A is the correct answer. Question number 29 is from gravitation, and the question is, two astronauts are floating in gravitational free space after having lost contact with their spaceship. The two will, option A, move towards each other, option B, move away from each other, option C will become stationary, and the last option is keep floating at the same distance between them. Okay, so the correct option will be option A, that they will move towards each other under the mutual gravitational force. Okay, under mutual gravitational force. Now question number 30 is from motion in a plane, and the question is, the x and y coordinates of a particle at any time are x equals to 5t minus 2t square and y equals to 10t respectively, where x and y are in meters and t is in seconds. The acceleration of the particle at t equals to 2 seconds is, okay, so the position of the particle is given, the x coordinate is given as 5t minus 2t square and the y coordinate is given as 10t. Okay, so we can find the velocity for each coordinate. Vx will be equal to what? Dx by dt. So on differentiating 5t minus 2t square, what do we get? We'll get 5 minus 4t. Okay, so this is the velocity. Similarly, this side Vy will be equal to dy by dt. That means we'll differentiate 10t. So here we get 10 only. Okay. Now we have to find the acceleration. So how to find the acceleration? Acceleration will be the differentiation of velocity. So dvx by dt. That means d of differentiation of 5 minus 4t, and that will be equal to minus 4 only, because 5 is a constant, it will be 0. This side it will be minus 4. And this side it will be dvy by dt. That means we have to differentiate a constant only, 10, right? So the differentiation of constant is 0. So this will be 0. That means y coordinate is the acceleration here in this case is 0. Only -4 is the acceleration. So the required acceleration is -4 I cap only. Okay. And the unit is meter per second square. So the correct answer will be -4 meter per second square. So option B will be the correct answer. T equals to 2 seconds is of no use here because we don't have any t left after differentiating this. Okay. So option B will be the correct answer. Now question number 31 is from the circular motion, and the question is one end of string of length L is connected to a particle of mass M and the other end is connected to a small peg on a smooth horizontal surface, horizontal table. If the particle moves in circle with speed v, the net force on the particle will be. Okay. So we have to find the net force, and this force should be directed towards the center, and T represents the tension in this string. Okay. So we have a table here, right? And here a particle is moving in circular motion. This tension in the string is T. So the only force that will be acting on this particle towards the center will be the centripetal force, and that centripetal force will be provided by this T. Okay. So the only force, or you can say the net force on the particle, on the particle is tension T, okay, and that will provide the centripetal force. So that will be equal to mv square by L. So the correct option will be option D. Okay. Question number 32 is from simple harmonic motion, and the question is a particle executes linear simple harmonic motion with an amplitude of 3 centimeter. When the particle is at 2 centimeter from the mean position, the magnitude of its velocity is equal to that of its acceleration. Then its time period in seconds is. Okay. So what does it say? It says that when the amplitude is 3 centimeter and the position of the particle, that is x is equal to 2 centimeter, then in this case the magnitude of velocity becomes equal to the magnitude of acceleration. Okay, so this is the case. Now what is the formula of velocity? We know that v will be equal to omega under root a square minus x square. Okay, a is the amplitude and x is the position, and acceleration, that means a will be equal to omega square x. Okay, so this you have to remember. So in this case both become equal. That means omega square x becomes equal to omega under root a square minus x square. So 1 omega will be cancelled. That means omega x will be equal to under root a square minus x square. So omega will be equal to what? Under root a square minus x square upon x, right? So let's put the values. A is equal to 3 centimeter. So a square means 3 square. X is equal to 2 centimeter. So 2 square divided by 2. Okay. So here we get 3 into 3 square, that means 9. 2 square minus 4. So it will be root 5 by 2. Okay. This is the value of omega. But we have to find out the value of time period. Okay. So omega is given as under root 5 by 2. So omega can be written as 2 pi by t. Okay, so that is equal to root 5 by 2. So what will be the value of t? T will be equal to 2 pi by root 5 into t. That means 4 pi by root 5. Okay, so which option will be correct? Option B will be the correct answer. Time period is equal to 4 pi by root 5. Question number 33 is from the chapter Wave Optics, and the question is two Polaroids P1 and P2 are placed with their axis perpendicular to each other. Unpolarized light I0 is incident on P1. A third Polaroid P3 is kept in between P1 and P2 such that its axis makes an angle 45 degree with that of P1. The intensity of transmitted light through P2 is. Okay, so first we have two Polaroids P1 and P2. So let's say this is P1 and this is P2. Now the unpolarized light that is incident on P1 has the intensity I0 Also, it is given that these two polarites have their axis perpendicular to each other. That means if we say the angle between P1 and P2, it is 90 degree. Okay, these are perpendicular. Then a third Polaroid P3 is placed in between these two Polaroids. So let's say this is P3. Okay. Now, what will happen once this unpolarized light comes out from P1? It will have the intensity. Let's say this is I1. I1 will have the intensity I0 by 2. Okay. Now this P3 has its axis at 45 degree with that of P1. Okay. This angle is 45 degree. Then this light of intensity I0 by 2 will enter this P3. Okay, so the light that will come out of this P3 will have the intensity. If this is I1, then it will be I1 cos square theta. Okay, and I1 is I0 by 2. Theta is 45 degree, so cos square 45 degree. That means cos 45 degree is 1 by root 2. So 1 by root 2 square. So it will be equal to I0 by 4. Okay. Now this light with intensity I0 by 4 will be entering this P2. Okay. And what is the angle here? Again, it will be 45 degree because we know that the angle between P1 and P2 is 90 degree. And the angle between P1 and P3 is 45 degree. Therefore, the angle between P3 and P2 will also be 45 degree. Okay, so the total will add up to 90 degree. So again, so let's say this is I2. Okay, so the intensity of the light that will come out of P2 will be I2 cos square theta. Okay, so I2 is what? I0 by 4, and again theta is 45 degree. So it will be I0 by 4, again square of 1 by root 2. So it will be equal to I0 by 8. So this is the final intensity of the light that will come out of the P2. So the correct option will be option B, I0 by 8. Question number 34 is from the chapter Mechanical Properties of Solids. And the question is, the bulk modulus of a spherical object is B. If it is subjected to uniform pressure P, the fractional decrease in radius is. Okay. See, it is a spherical object. So we know that volume of a spherical object is 4 by 3 pi r cube. That means volume is proportional to r cube. That is third power of radius. Okay. So what will be delta V by V? It will be equal to 3 delta R by R. Okay. So this you have to keep in mind. Now, what is the formula for bulk modulus? It is equal to pressure divided by delta V by V. Okay. And what will be the delta V by V? It will be equal to pressure divided by bulk modulus. Right. Now, we know that delta V by V is equal to 3 delta R by R. So let's put it here, 3 delta R by R. Delta R by R is what? It is the fractional decrease in radius, right? So that we have to find. We have to find the value of delta R by R. So that will be equal to delta R by R will be equal to P by 3B. Okay. That means option C will be the correct answer. Okay. Now question number 35 is related to electromagnetic theory, and the question is, in an electromagnetic wave in free space, the root mean square value of the electric field, that is ERMS, is 6 volt per meter. The peak value of the magnetic field is, okay, peak value, that means B naught we have to find. Now we know that the ratio of the RMS value of electric field to that of magnetic field, that means ERMS by BRMS, is equal to the C, that is speed of light. Okay, so that is equal to 3 into 10 to the power 8 meter per second, right? Here ERMS is given as 6 volt per meter, BRMS is not given, and this ratio is equal to 3 into 10 to the power 8 meter per second. So we can find out the value of BRMS from here. This will be equal to the ERMS, that means 6, divided by C, that is 3 into 10 to the power 8. So here we get 2 into 10 to the power minus 8. Okay, this is the value of RMS value of the magnetic field. Okay, but we have to find out the peak value, that is B naught. So that is equal to root 2 times BRMS, right? That means root 2 times 2 into 10 to the power minus 8. We are putting the value of BRMS. Root 2 is equal to 1.414 into 2 into 10 to the power minus 8. So on solving this, we get 2.83 into 10 to the power minus 8, and the unit will be Tesla for magnetic field. So the correct option will be option number A. Okay. Now question number 36 is from rotational motion, and the question is, a rope is wound around a hollow cylinder of mass 3 kg and radius 40 centimeter. What is the angular acceleration of the cylinder if the rope is pulled with a force of 30 Newton? Okay. So force is given as 30 Newton, then mass is given as 3 kg, radius is given as 40 centimeters, so in meter it will be 0.4 meter. Okay, and we have to find out the angular acceleration, that is alpha. Now we know that in linear motion F is equal to ma. Similarly in rotational motion torque tau is equal to I into alpha. Okay, now we have to find out the alpha, so that will be equal to torque divided by moment of inertia I. Okay, now torque is equal to force into the perpendicular distance, that is F into R, and moment of inertia will be equal to mr square. Okay, so let's put these values here. F into R divided by mr square. So 1r will be cancelled here. So it will be F divided by mr. Okay, now let's put the values. Force is given as 30 Newton. So 30. Mass is given as 3 kg and radius is 0.4 meter. Okay, so here we get 10 divided by 0.4, that is 100 divided by 4. So it will be 25 and the unit will be radian per second square for alpha. Okay, angular acceleration has unit radian per second square. That means option B will be the correct answer. It is 25 radian per second square. Now question number 37 is from the chapter Systems of Particles and Rotational Motion, and the question is, two disks of same moment of inertia are rotating about their regular axis passing through center and perpendicular to the plane of disk with angular velocities omega 1 and omega 2. They are brought into contact face to face coinciding the axis of rotation. The expression for loss of energy during the process is, okay, so we have two disks here. This is disk 1, this is disk 2. The first one is rotating with an angular velocity omega 1 and the second one is rotating with an angular velocity omega 2. Okay, the moment of inertia is same for both, that is I. Now these two are brought in contact such that the axis of rotation is coinciding. Okay, and these two disks are facing each other. So what will happen to the moment of inertia? It will get added. So the final moment of inertia of this combination will be 2I. Okay, and what will happen to the angular velocity? That we don't know, we have to find out. So let's write omega c for the combined angular velocity. Okay, now we know that no external torque is being applied here. So external torque is 0 and the angular momentum will remain constant. Okay, that means the total initial momentum will be equal to the total final momentum. So by conservation of momentum, we can say that the total initial momentum will be equal to the final momentum. Initial momentum of the first one was I omega 1, for the second was I omega 2. So that will be equal to the final momentum, that means 2I into omega c. Okay, if we take I common this side, so here we get I omega 1 plus omega 2 equals to 2I omega c. So we can say that omega c, that is combined angular velocity, is equal to omega 1 plus omega 2 divided by 2. Okay, so this is the expression for the combined angular velocity, but we have to find the expression for the loss of energy. Okay, now energy is lost, that means energy will decrease. So the final energy will be less than the initial energy. Okay, let's write it down here. What is the initial energy? Initial kinetic energy will be the sum of kinetic energies of the two disks. So for the first one it will be half I omega 1 square, and for the second one it will be half I omega 2 square. Okay, so this is the total initial kinetic energy. And what will be the final kinetic energy? Final kinetic energy will be equal to half, the moment of inertia for the combination is 2I, right? So 2I, and the angular velocity is omega 1 plus omega 2 divided by 2 that we have just found out. Okay, so omega 1 plus omega 2 divided by 2 whole square. Okay, so let's solve this. Here this 2 will be cancelled. So I this side, and this side omega 1 plus omega 2 whole square is there. So it can be written as a plus b whole square, right? So a square, that is omega 1 square, plus b square, that is omega 2 square, plus 2ab, that is 2 omega 1 omega 2, divided by square of 2 is 4, right? Now on opening the bracket, what do we get? Here we get I by 4 omega 1 square plus I by 4 omega 2 square plus I by 2 omega 1 omega 2, right? So this is the final kinetic energy. This is the initial one, this is the final one. Now loss will be the difference in both. Okay, so loss in energy is equal to the total initial kinetic energy minus final kinetic energy. Okay, so initial kinetic energy is this one, that is half I omega 1 square plus half I omega 2 square, and the final one is this one, that means 1 by 4 I, or I by 4 omega 1 square plus I by 4 omega 2 square plus I by 2 omega 1 omega 2, right? Now we have to solve this. So we'll open the bracket, 1 by 2 I omega 1 square plus half I omega 2 square minus 1 by 4, or I by 4 omega 1 square minus I by 4 omega 2 square, because minus sign is there, so sign inside the bracket will change. Okay, I by 2 omega 1 omega 2. So this side we have half I omega 1 square, and this side we have 1 by 4 I omega 1 square. So it will be, on subtracting, we'll get 1 by 4 I omega 1 square. Okay, then this side we have half I omega 2 square, this side also we have 1 by 4 I omega 2 square. So on subtracting, what do we get? We'll get 1 by 4 I omega 2 square. Now what is left here? Only this one is left, that means minus 1 by 2 I omega 1 omega 2. Okay, now let's take 1 by 4 outside the bracket. So what will be inside the bracket? It will be I omega 1 square plus I omega 2 square minus 2I omega 1 omega 2. We should have taken I also outside the bracket, right? So let's take it outside the bracket. I by 4, inside the bracket what is left? Omega 1 square plus omega 2 square minus 2 omega 1 omega 2. Okay, you can do this in one step only. I just forgot to take I outside the bracket, that's why. Now this is in the form of a minus b whole square, right? Because this is equal to a square plus b square minus 2ab. So simply we can write omega 1 minus omega 2 square, isn't it? So it will be equal to I by 4 omega 1 minus omega 2 whole square. So this is the expression for loss in energy. Okay, this was lengthy, but you can do it carefully. So I by 4 omega 1 minus omega 2 whole square. So let's see which is the correct option. I by 4 omega 1 minus omega 2 whole square. That means option A seems to be the correct one, right? Yes, option A is the correct answer. Now question number 38 is from photoelectric effect, and the question is the photoelectric threshold wavelength of silver is 3250 into 10 to the power minus 10 meter. The velocity of the electron ejected from a silver surface by ultraviolet light of wavelength 2536 into 10 to the power minus 10 meter is. Okay, we have to find out the velocity of the electron. Now what is given in this question? The threshold wavelength of silver is given. That means lambda naught is given as 3250 into 10 to the power minus 10 meter. That means 3250 angstrom. Okay. And the wavelength of the ultraviolet light, that is lambda, is given as 2536 into 10 to the power minus 10 meter. That means 2536 angstrom. The value of Planck's constant as well as the speed of light is also given, and we have to find out the velocity of the electron that will be ejected from the surface of the silver. Okay, so we know that the maximum kinetic energy, that is Ke max, will be equal to hc by lambda minus hc by lambda naught. Maximum kinetic energy will be half mv square, and this side if we take hc common, here we'll have 1 by lambda minus 1 by lambda naught. Now we have to find out the value of this velocity v. Okay, so v will be equal to what? 2hc by m 1 by lambda minus 1 by lambda naught and root of this, right? Because in formula we had v square. So now we can put the values. We know that the product of Planck's constant and speed of light, that is hc, is equal to 12400. Okay, and here if we look at this question, the value of Planck's constant is given in electron volts. So in order to convert it into joule, we have to multiply it by 1.6 into 10 to the power minus 19. Okay, then we'll get the value in joule. So here let's put the values. The value of hc is 12400 into 1.6 into 10 to the power minus 19 joule divided by mass of the electron will be what? 9.1 into 10 to the power minus 31 kg. Okay, this is the mass of the electron, and this side we have 1 by lambda minus 1 by lambda naught. So what is the value of lambda? 2536 angstrom. Okay, 2536 minus 1 by lambda naught. So lambda naught is 3250 angstrom. 3250 angstrom. Now first we have to solve this bracket, and then we have to solve this complete expression, and that you have to do. This is a quite a lengthy solution, but you have to do it. And after solving this, you'll get around 0.6 into 10 to the power 6 meter per second. Okay, now if you get this type of question in exam, you have to leave it and you need to solve it only if you have enough time. Okay, because this is lengthy calculation. So according to this, our correct option will be option number A. Now question number 39 is from magnetism, and the question is a 250 turn rectangular coil of length 2.1 centimeter and width 1.25 centimeter carries a current of 85 microampere and subjected to magnetic field of strength 0.85 Tesla. Work done for rotating the coil by 180 degree against the torque is. Okay, so work done will be equal to mb cos theta 1 minus cos theta 2. Now theta 1 is 0 degree here and theta 2 is 180 degree, right? So let's write it down. mb cos 0 degree minus cos 180 degree. Now 0 degree, cos 0 degree is equal to 1 and cos 180 degree is minus 1, so it will become 1 plus 1. Okay, so we'll get 2 mb. Now m is equal to nia, right? So let's write it down. 2 into nia. N is the number of turns, I is the current, and A is the area, and B is the magnetic field. Okay, now magnetic field strength. So let's put the values here. 2 into number of turns is given as 250. Current is given as 85 microampere, that means 85 into 10 to the power minus 6 ampere. Then area will be length into breadth. So length is 2.1 centimeter, that means 2.1 into 10 to the power minus 2 meter, and breadth is or width is 1.25 centimeter, again 1.25 into 10 to the power minus 2 meter. Okay, and then we have the magnetic field strength, that is 0.85 Tesla. Now if you solve this, the value that you will get will be closest to this last option, that is around 9.1 into 10 to the power minus 6 joule, or 9.1 into 9.1 microjoule. Okay, so option D will be the correct answer. You might not get this exact value, but the value will be closest to this option. Therefore, option D will be the correct answer. Question number 40 is from the chapter Atoms, and the question is the ratio of wavelengths of the last line of Balmer series and the last line of Lyman series is. Okay, so we have to find the ratio of last line of Balmer and that of Lyman series. Okay, now we know that in case of Balmer series, N1 will be equal to 2, whereas in case of Lyman series, N1 will be equal to 1. Now, since we are talking about the last lines, so N2 will be infinity for both. Okay. Now, we know that 1 by lambda is equal to Rz square, 1 by N1 square minus 1 by N2 square, right? So, we'll put this formula for each one of them. So, for Balmer series, 1 by lambda B will be equal to Rz square, 1 by N1 square, that is 2 square, minus 1 by N2 square, that means 1 by infinity square. Similarly, for Lyman series, 1 by lambda L will be equal to Rz square, 1 by N1 square, that means 1 square, minus 1 by N2 square, that is infinity square again. Now, in case of Balmer, it will be Rz square, and this side we get 1 by 2 square, that means 4 square. Okay, 1 by 4 square, and 1 by infinity square will be equal to 0. So here it will be 1 by 4 only, so Rz square by 4. So what will be the value of lambda? Lambda B will be equal to 4 divided by Rz square. Okay, so this is the wavelength for the last line of Balmer series. Now in case of Lyman, 1 by infinity square will be equal to 0, and 1 by 1 square will be equal to 1 only. So this will be equal to Rz square only. Okay, so lambda L will be equal to 1 by Rz square. Now we have to find out the ratio of these two. So ratio of lambda B divided by lambda L will be equal to 4 by Rz square into Rz square. That means it will come out as 4. So correct option will be option B, that is 4. Okay. Question number 41 is from the chapter Thermodynamics, and the question is a Carnot engine having an efficiency of 1 by 10 as heat engine is used as a refrigerator. If the work done on the system is 10 joule, the amount of energy absorbed from the reservoir at lower temperature is. Okay. So what is the coefficient of performance of refrigerator, that is beta? It is equal to Q2 by W. Okay. W is the work done. And what are Q1 and Q2? Q1 means heat released from the hot reservoir. Okay. Heat released from the hot reservoir. Whereas Q2 is the heat absorbed from the cold reservoir. Okay. So heat absorbed from the cold reservoir. So here the coefficient of performance of refrigerator will be Q2 by W. Also it is equal to 1 minus eta by eta, where eta is the efficiency. So eta is given as 1 by 10, right? That is 0.1. So let's put the values. Q2 is unknown, that we have to find out. Work done is given as 10 joule. 1 minus eta, that is 1 minus 0.1, divided by eta, that is 0.1. So from this equation we can find out the value of Q2. So Q2 by 10 will be equal to 1 minus 0.1, that is 0.9 by 0.1, so it will be 9, and Q2 will be equal to 9 into 10, that means 90 joule. Okay, So Q2, that is heat absorbed from the cold reservoir or heat absorbed from the reservoir at lower temperature, is equal to 90 joule. Therefore, option A will be the correct answer. Question number 42 is from kinetic theory, and the question is, a gas mixture consists of 2 moles of oxygen and 4 moles of argon at temperature T. Neglecting all vibrational modes, the total internal energy of the system is. Okay, so here we have to remember one thing, that oxygen is a diatomic gas. Therefore, the degree of freedom for oxygen will be 5. Okay, whereas argon is monoatomic gas. Therefore, degree of freedom for argon will be 3. Right? And we know that the internal energy U is equal to F by 2 nRT. So if we talk about the oxygen, so for oxygen, the internal energy delta U1 will be equal to 5 by 2 nRT. Okay, because degree of freedom is 5 here. Whereas in case of argon, the internal energy, let's say delta U2, will be equal to 3 by 2 nRT, because the degree of freedom is 3 in this case. Okay, and we have to find out the total internal energy. So the total internal energy of the system will be equal to the internal energy of the oxygen delta U1 plus internal energy of the argon delta U2. Okay, for oxygen the internal energy was 5 by 2 nRT, and for argon it was 3 by 2 nRT, right? Let's take RT common. So here we get 5 by 2, and N, that is number of moles of oxygen, is 2. So it is 2 plus, for argon number of moles is 4. Okay, so this 2 into 2 is cancelled and 2 into 2 is 4. So here we get 5 plus 3 into 2, that is 6. So 6 plus 5 is 11, that is 11 RT. So this is the total internal energy of the system. Okay, that means option number C will be the correct answer. Now question number 43 is from magnetic effects of current, and the question is, an arrangement of 3 parallel straight wires placed perpendicular to the plane of paper carrying same current I along the same direction is shown in figure. Magnitude of force per unit length on the middle wire B is given by. Okay, we know that whenever we have 2 parallel wires and the current is in the same direction, then there will be force of attraction between these 2 wires. Okay, so here wire A and B is parallel to each other and the current is moving in the same direction. Okay, so there will be force of attraction between A and B. Okay, there will be force like this. Also there will be force of attraction between B and C due to the same reason. Okay, so if we talk about the wire B, because the question is asked about B, so one force will be in this direction due to wire A and the other will be in this direction due to wire C. Okay, let's say this is F1 and this is F2. So the net force will be in this direction, right? Force per unit length, let's write it F1 by D because the distance is D, and force per unit length for this one is F2 by D. Okay, so the net force will be what? F1 by D square plus F2 by D square and root of this. Okay, under root F1 by D square plus F2 by D square. Now we have to find out the value of F1 by D and F2 by D. So this will be equal to mu naught I1 I2 divided by 2 pi D. This is the formula for force per unit length, and since I1 and I2 is same, the current is same, so it can be written as mu naught I square by 2 pi D. And same will be the value of F2 by D because the value of current as well as the distance remains same. Okay, so let's put the values. Net force will be equal to under root F1 by D square, that means mu naught I square by 2 pi D square plus F2 by D square, again the same value, mu naught I square by 2 pi D square. Okay, so both are same, so we can write it as 2 times mu naught I square by 2 pi D square. So 2 can be taken out, it will be root 2, and the root of this square will be mu naught I square by 2 pi D only. Now this root 2 will be simplified here, root 2. Okay, so it will be mu naught I square by root 2 pi d. Okay, so this will be the net force per unit length. That means option C should be the correct answer. Now question number 44 is from mechanical properties of fluids, and the question is a U tube with both ends open to the atmosphere is partially filled with water. Oil which is immiscible with water is poured into one side until it stands at a distance of 10 mm above the water level on the other side. Meanwhile, the water rises by 65 mm from its original level. The density of the oil is, okay. So here this is the level of water, okay, and the level of oil is 10 mm above the water level here. Okay, this is the level of oil. Now we know that at this level from B to C the pressure will be same, because in the same liquid the pressure at the same level is same. Okay, pressure at same level will be same. So if we take pressure at point B as P1 and the pressure at point C as P2, then P1 will be equal to P2. Okay. And the pressure is equal to atmospheric pressure, that is P naught, plus rho GH. So on the left side it will be the rho, that is density of oil, so rho O, and height of oil, that is HO. Okay. And on the right side it will be P naught, that is atmospheric pressure, plus rho GH. This time rho will be the density of water and height will be the height of water. Okay. Now P naught is on both sides, atmospheric pressure, so cancelled. So rho O G and HO will be equal to rho of water G and H of water. Again G is same, and we have to find out the density of oil, that is rho O. So that will be equal to density of water into height of water upon height of oil. Okay. Now let's put the values. The density of water will be 10 to the power 3. Then height of water. See, this is the height of water, right? So from here to here we have 65 millimeter plus 65, that is 130 millimeter. Okay. So 130 into 10 to the power minus 3 meter divided by height of oil. So height of oil is 10 millimeter above the level of water, that is 140. Okay. So 140 into 10 to the power minus 3 meter. Now on solving this we'll get 928 kg per meter cube. Therefore correct option will be option number C. This is the density of oil. And now the last question is from systems of particles and rotational motion. And the question is, which of the following statements are correct? So first statement says center of mass of a body always coincides with the center of gravity of the body. This is not true. This may coincide, this may not coincide. Okay. It depends from place to place. So this is incorrect statement. Second statement says center of mass of a body is the point at which the total gravitational torque on the body is zero. So this is actually a definition of center of gravity. Okay, because center of gravity is the point at which the total gravitational torque on the body is zero. But in some situation, when the center of mass of the body coincides with the center of gravity, in that case this statement may be true for the center of mass. Okay, so this is partially correct, you can say, because it is conditional, right? Then the third statement says a couple on a body produce both translational and rotational motion on the body. This is not true, because a couple only produces rotational motion. Okay, rotational motion and no translational motion. So this is incorrect. And the last statement says mechanical advantage greater than 1 means that small effort can be used to lift a large load. Okay, so mechanical advantage can be represented as load by effort. So if mechanical advantage is greater than 1, it means that effort will be low. Okay, lesser effort will lead to a larger mechanical advantage. Therefore this is a correct statement. So here we have to find two correct statements, and we had seen that statement B was also partially correct, so we will take these two as the correct statements. So option D will be correct. B and D both will be the correct statements. Okay. So here we complete all the physics questions from NEET paper 2017. We'll be back with another session soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice same questions from our website www.examsnet.com, and for more information, download our app from the link given in the description. Thank you so much.